Hello, my name is Ryan Jansen, co-founder and CTO of TransPod, where we're designing ultra-high-speed ground transportation. This is a Canadian-European project, especially also with Italy and France. What I think you might be the most interested in about this presentation is the combination of space research with aviation and railway industry expertise under one holistic design. And so if you will, I will explain a little bit about the TransPod system. So the TransPod system is ultra high-speed ground transportation and actually tube transportation. So TransPod vehicles, you see one here, are being designed for travel at over 1,000 kilometers per hour under magnetic levitation and propulsion, similar to certain types of maglev systems, but with key new innovations, but propelled within low-pressure tubes to reduce air resistance and carry passengers between stations at over 1,000 kilometers per hour. If you really look at the history of tube transportation, it was first proposed about 100 years ago and gradually developed over the years, and even you could say popularized a few years ago. But now it's time for key new innovations. That's where the TransPod system comes into play, where we have new technologies partly related to aerospace, partly related to rail and infrastructure to make the system work more efficiently. And that's the TransPod vehicle and the TransPod infrastructure are really what work together in a matched pair to make the TransPod system as a whole work for passenger transportation as well as cargo transportation. And so obviously this is a major multi-year project with very extensive industrial work internationally, with multidisciplinary work across areas of civil engineering, physics, electrical engineering, aerospace, and so on. And really you can trace back and ask, why are we doing this? Well, as a society, we're confronted with issues of traffic congestion, really with existing vehicles. We have key issues to deal with, but also climate change, where you have quite a bit of fossil fuels still in use, and quite a bit of that is for the transportation industry, because we have existing vehicles that are very fossil fuel dependent, including aircraft where they require a very energy dense fuel. So we really look to the bigger picture and fundamentally new vehicle designs and infrastructure designs to carry those new vehicles. And in particular, looking at the low pressure of space and bringing that near vacuum down to Earth inside a contained infrastructure provided by vacuum pumping and supporting propulsion systems, and that's what the TransPod system becomes. And in fact, when you see renderings like this, it's important to note that it's clear, but it's just in the rendering to help you see the vehicle inside, but the actual TransPod infrastructure is not clear. It's spiral welded steel construction with the supporting electrical, fire safety, vacuum pumping, and other supporting subsystems. And so a major engineering project that is very international in scope, and so it's a TransPod design, but it's also with key industrial collaborators. And so, for example, that includes CITEL, which is based in Italy, and so their expertise in spacecraft design, propulsion, and space systems. So key expertise in those areas, as well as Merrimack, the train industry, and Black Shape Aircraft, who are also based in Italy. But then beyond that, internationally, in Canada, the US, and France, so quite a few other collaborators, even beyond this list, who are joining the consortium to be able to develop many of the different subsystems in collaboration with TransPod, partly from the rail industry and aerospace and government sector as well. So obviously it's a multi-year project to design similar to an aircraft design program. And so in fact, this TransPod vehicle, it might appear a bit similar to an aircraft fuselage without the wings. And at the front, you see what looks like a jet engine, but it's actually an electrically driven axial compressor to help divert airflow in a small amount of air pressure that still exists in the tube infrastructure, divert some of that airflow to reduce air resistance even further. And then also magnetic propulsion and levitation systems, thermal control systems, and so on, plus passenger seating. That is, you see a bit of a door there, but this vehicle is a bit larger than it appears in this diagram. But rows of seating similar to on an aircraft, even though a lot of the supporting systems are more related to the space industry in the TransPod vehicle. And so a twin tube construction to allow vehicle motion in both directions with multiple vehicles in the line, even in each direction at the same time, with appropriate separation distances and safety provisions similar to the rail industry. And the infrastructure is actually designed to be linked to the electrical grid for fully electric propulsion, where the power is carried over onto the vehicle's third rail type of power transmission, so it's fossil fuel free propulsion. So sustainability is a key factor, but even the mechanics of the docking procedures of the TransPod vehicles at stations is very critical, along with all of the fluid dynamics, aerodynamics, similar to high altitude flight systems, but inside the protected environment of a tube where you have aircraft-like flight and flight maneuvering, but protected from the elements, protected from turbulence, and so on. And so all of the supporting subsystems, electrical systems, safety systems, pressure management, and cabin air systems in the vehicle, but then of course the similar supporting systems, safety, fire safety, evacuation, similar onto a metro line on the tube infrastructure. Now when you have tube infrastructure such as this, it starts to become quite a bit like a rail system design. And so then you have provisions for rail types of passenger flow calculations for high frequency rail line and vehicle spacing and other rail-like safety and design issues. That so it's again an interesting combination of spacecraft, aviation, and railway design. But then the economic features that we are designing for, partly economic for the consumer, so ticket price, but also the speed and convenience. So it's fundamentally a different type of transportation than going to an airport where you have to book a ticket weeks in advance or days in advance for a specific time to show up at the airport. And even then, you're subject to the flight being delayed, canceled, or diverted, or being bumped from your seat. But this is much more like a railway, high-frequency rail experience where you simply show up to a station and pay for your ticket. And so that type of passenger experience leads to the architectural designs. We're working with an architectural firm, but really it's integrated with all of the physics considerations for the infrastructure that support these low pressure environments where a vehicle goes through an airlock and enters into what becomes much more like a rail station. And so we can see a little bit of a preview of one of the stations that we are working on. This in collaboration with a French firm, but this is actually located in Toronto, which is a planned construction project, a very major project, which is a multimodal station where we're collaborating on the TransPod portion of that station to link up with additional modes like metro and regional rail. And when you look at it, it's quite a bit more of a combination of some airport features as well as train station features as the passengers pay for their tickets and board, where the platforms are similar to a rail, but the vehicles themselves, after going through airlocks into the atmospheric pressure zone, have a certain docking procedure, and that actually is supported by a Spanish solution style of a design where passengers disembark on one side and board on the other side for the vehicle throughput to maximize efficiency and the lower throughput time, delay time at the stations, and propelling under their own propulsion from electrically driven into airlock and into the high-speed zone of the tube. And so that really means that there are quite a few design aspects that we are working on with major construction firms in different countries on consulting with the construction aspects as well as the aerospace design features. So it's very multidisciplinary, and then even human-centered design, so for example, seating inside much more of as well as cargo design. Cargo vehicles which have the same propulsion systems but just a different interior, and so the markets for that are quite key when you have just-in-time deliveries and high value density goods that are time critical in today's economy. But even the physics of quite a few innovations in the TransPod system that are partly with vehicle control and which is similar to a flight control system, but also intelligent sensing systems and innovations with propulsion, where you have to have very low latency real-time control because it's much too fast for any human driver. And so the right type of control and analysis of aerodynamics. So this is a very multi-year project where one of the key considerations is certification and safety and validation and verification, which comes partly from the rail industry and as well as aerospace. And so that's why we are starting work already with European and Canadian regulatory agencies to establish regulatory frameworks for the TransPod system for long-term success as we work towards implementation and integrate all of the systems. So it's a multi-year project with many industrial collaborators in Canada and Europe. So pleasure working with all of them, and I would encourage you to read more if you're interested in the TransPod system and innovations that we are working on. So I hope that you have learned a little bit about that system and would be looking forward to collaborating with any of you in the future. So thank you very much.